Hello, everyone, and welcome to this teacher workshop on using manipulatives with the CPA approach in grade 7 through 9. Today, we'll explore how concrete, pictorial, and abstract thinking work together to deepen student understanding in pre algebra, algebra 1, and geometry. Even at the secondary level, students benefit tremendously from hands on tools. Manipulatives make invisible math visible. By the end of this workshop, participants will be able to explain the CPA concrete, pictorial, and abstract instructional model and its relevance to grades 7 through 9, identify and use common manipulatives to teach pre-algebra, algebra 1, and geometry concepts, design lessons that move students from concrete models to pictorial representations to abstract notation, model algebraic and geometric ideas using hands-on tools and visual diagrams, and integrate CPA strategies into daily instruction to increase student understanding and engagement. What is CPA? CPA stands for Concrete, Pictorial, and Abstract. Concrete means students physically build or model the mathematics. Pictorial means they draw what they built using diagrams, tiles, graphs, or sketches. And abstract is the symbolic representation, what it means, equations, formulas, and proofs. The biggest misconception is that manipulatives are only for younger learners. In reality, complex ideas in algebra and geometry require strong conceptual grounding. CPA gives students a bridge instead of a jump. Even though students are moving into symbolic algebra and formal geometry, CPA still builds conceptual understanding before procedures, helps struggling learners transition to abstraction, supports multi step reasoning, makes algebraic and geometric ideas visual and tactile. So, yes, it's not only possible but very valuable for pre algebra, algebra 1, and geometry. In grades 7 to 9, concretes includes algebra tiles, integer chips, balance scales, geoboards, 3D models, paper nets, and dynamic geometry tools. Students first build a concept with manipulatives and then draw diagrams to represent the model, and finally transition to symbols, equations, and formal reasoning. Research shows that CPA improves retention, problem solving, and conceptual understanding, making abstract math more accessible and meaningful. In pre-algebra, manipulatives help with integers, equations, and proportional reasoning. For example, integer chips for visualizing positive and negative quantities, balanced models for solving one and two step equations, double number line strips for ratios and proportions, algebra tiles for combining like terms and the distributive property. And after building with manipulative, students sketch the model and then finally they write the equation or solve it symbolically. In Algebra 1, the abstract level becomes dominant, but manipulatives still play a crucial conceptual role. Like, for example, algebra tiles for factoring and expanding polynomials, tile area models for understanding the structure of quadratics, graphing tiles or string on a coordinate grid to demonstrate slope, color chips to model systems of equations, function machine cards for introducing input and output rules. Students move from physical tiles to drawn area models, then to equations, and this progression prevents memorization without understanding the process. Geometry becomes far more intuitive through hands-on models, like for example, geoboards to explore polygons, slopes, and triangle areas, pattern blocks for angle relationships, paper nets and 3D solids to understand surface area and volume, mirror lines to demonstrate reflections, and sliding and rotating cutout shapes to show congruence and rigid motions. Dissection tiles for proving the Pythagorean theorem. Students begin with physical models, sketch diagrams of the transformations or nets, and move into the formal geometric notation and proofs. Using manipulatives doesn't have to take long. Here are easy routines. Warm up build. Students model a problem in 2 minutes. Sketch it. They translate the model into a picture. Connect it. They write the abstract notation and then explain it. Students justify how the model matches the math. These three steps build sketch. These three steps build sketch symbol, create deep understanding. Common objects that work as manipulatives. General or pre-algebra. Many manipulatives do not need to be purchased. Common classroom items work perfectly. Like for a pre-algebra, bottle caps make great integer chips, and paper clips can act as ratio strips or counters. Index cards are useful for function machines or step-by-step equation modeling. Straws and string can represent geometric lines, and play money is perfect for modeling positive and negative values. Color sticky notes help students visually combine like terms, and clothespins can be used to create simple balance scale models. These everyday items make hands-on learning both accessible and affordable. For Algebra 1, simple materials can stand in for more formal manipulatives. Cut up pieces of colored papers function as inexpensive algebra tiles. Popsicle sticks work well for modeling arithmetic and geometric patterns. Yarn or string can be stretched across a coordinate grid to demonstrate slope. Painter's tape is great for creating coordinate axes or showing transformations right on the classroom floor. And small dry erase tiles can represent graphed points or movable components in a function. These items make abstract algebra ideas easier to see and manipulate. In geometry, many low-cost materials can bring shape and space to life. Toothpicks allow students to build triangles and polygons. Rubber bands can serve as a simple substitute for geoboard. Cardboard nets help students explore 3D solids, surface area, and volume. Mirrors make reflections and symmetry more concrete. Printable pattern blocks, templates, and tangram pieces support work with angles, congruence, and composition of shapes. Even sponges or small blocks can be used for modeling volume and surface area. These hand on materials make geometry reasoning tangible. Digital tools also serve as powerful manipulatives for grades 7 to 9. GeoGebra allows students to build, slide, rotate, and measure geometric objects dynamically. Desmos Geometry offers an intuitive space for constructing shapes and exploring transformations, and virtual algebra tiles, available in many free online versions, help students model expression, equations, and factoring. These digital manipulatives provide the same conceptual benefits as physical tools, with the added advantage of being accessible to all students. Thank you for participating in the CPA Manipulatives Workshop for grades 7 to 9. Remember, manipulatives aren't a replacement for an algebraic reasoning, they are the foundation that makes reasoning possible. When students can build it, they can understand it, and when they understand it, they can perform at higher levels. Before we wrap up today's workshop, I need everyone to complete the short post workshop form. You can access it by scanning the QR code if you prefer. This form helps verify your attendance, confirms you watched the full session, and gives me feedback so I can keep improving this training. It only takes about 3 to 5 minutes to complete. Once you finish the form, you're officially done with today's workshop. Please make sure to submit it before you leave or by the end of the day. If you have any trouble accessing the form, just let me know and I'll assist you. Go ahead and click on the link now and you may begin. These are the reference that I use for this workshop, and have fun. Thank you so much for your attention.